Hi, this is Samiran, and I'm going to continue from where Ashish left off. So once the robot has the internal matrix representing the floor, it's going to walk through the floor and it's going to take pictures at each cell of its surroundings, and then it takes 4 pictures at each cell and it stitches these together, and it does human recognition on these stitched images. It counts the number of human beings in the region, and based on the number of human beings in its surroundings, it assigns weights to the particular cell. These weights later get translated into weights for the whole region of the floor plan. We use these weights later during path planning to compute the path that has more landmarks, so which would be easier for the user to navigate. So what I'm going to do now is I'm going to show you how we've implemented the image stitching and the human computation, and then I'm going to switch over to the editor in the background and show you how we compute the path and how we present it in human understandable form. So let me just show you our images here. So there are 6 images. This is the left portion of the first image. This is the right portion of the first image. These are the left and right portion of the second images. These are the left and right portions of the third image. So when I run my code to stitch these images, 3 stitched images are going to be created, and a folder will be formed here with those stitched images, and I'm going to run human recognition on those stitched images after they're formed. So let me just run my code to stitch these images. So it's doing human recognition on only the left and right parts of the image. Later we'll do it on the stitched image as well. Okay. So as you can see, a folder called stitched has been formed here. This folder has 3 images. All these images are the stitched versions of the images I showed you before. Okay, so what I'm going to do now is I'm going to run my code to do human recognition on these stitched images. So as you can see, this is detecting the humans in the stitched image. Okay, so it's counting these human beings, and a floor matrix has been created, which has been passed to this code here. So this code receives the output of the previous section, which is a set of weights for each cell in the floor. This code creates a matrix of floor cell objects, which we call the plan, and each element of the matrix contains information about that cell in the floor plan, including the weights that we've computed based on the number of humans in the surroundings. So we use these weights to judge how popular a landmark is. So if the user wants to be directed through paths that have more landmarks, then we use these weights since we make the assumption that more humans are gathered in more popular landmarks over a long period of time. And these weights are updated every once in a while when the robot performs these walks and reaches the same cell again. So from the floor cell matrix, we generate a graph in which each region, not each cell, but each region is a node, and the edges in the graph represents the paths that the user can traverse while navigating through the floor. So let me just run this code and explain what it does. So as you can see here, this is the representation of the floor. C1 and C2 are classrooms here. P is any path between the rooms, the corridors, or anything that the user can traverse. RM and RF are male and female restrooms respectively. E1 and E2 are elevators, and S is the stairs. SB here is the most salient landmark we have here, which is a Starbucks. C1 is painted in red because it's the current location of the user, and the paths that we are going to show are going to originate from C1. So as you can see, it's asking if a landmark path is preferred. What this means is that do you want the shortest path to your destination, or do you want a path that contains more landmarks and is also short enough but will be easier to navigate? It may be a little longer than the shortest path, but it will have more landmarks and will be easier to navigate. So if I say no, it's only going to give me a shortest path. So if I say where is the closest washroom, so as you can see, it shows me a path to the closest washroom, which is a male washroom, and it paints the path in red. And one of the other features that we've implemented in our system is that it shows the path in English language as well. So it says move out of the classroom 1, take a right and go straight, take the first left. So as you can see, it's just converting this whole path here into English and presenting it. So we can add specific adjectives to our queries. For example, if I ask where is the closest female washroom, it's going to direct me to the closest female washroom here, and it's going to give me the directions in English language. Anyway, so let me just show one more feature and then I'll talk about the landmark path more. So if I say where is the closest elevator, so as you can see it directs me to the closest elevator here, which is E1. Now let's talk about paths with more landmarks. So for example, if I say I don't want the landmark path but I want the shortest path, and I ask for the stairs, so I ask how do I get to the stairs. So as you can see, it showed me the shortest path to the stairs and then presented the path in English as well. Now if I select yes for this question here, which means I want a path that is not as short as the shortest path but short enough but also contains landmarks, and I ask the same question again, how do I get to the stairs, then as you can see it directed me through a path that was not the shortest path. It contains a few nodes more than the shortest path, but it has a salient landmark which is Starbucks just close to the path. So it says move out of classroom 1, take a right and go straight, take the last left opposite to Starbucks and go straight till you reach your destination and go into your destination. So as you can see, it told me to go left opposite to Starbucks, which is easier to navigate than saying take a left here and then a left here, because there are no salient landmarks around this region. So that is in summary the whole project. So basically what we've done is we've tried to capture the number of human beings in the region and assign popularity to landmarks based on how humans gather around in a region over a period of time, and then we have used that weight to find the shortest path containing landmarks, more landmarks, to the destination that the user wants to go to. And we've also converted the directions into English language and presented them.